Hello. Today, we'll be covering advanced features of Java. Shall we get started right away? Here are the 4 topics we'll be learning today. First, wrapper classes that turn primitive types into objects. Next, strings. Second, ArrayList, which is a kind of array with a flexible size. Third, generics, which act like guardians to ensure the safety of your code. And finally, something like a box that can contain all of these. We'll also cover collections and iterators, which are like master keys that let you look through the contents of a collection. As I just mentioned, the first topic is wrapper and string classes. These are very basic yet essential classes. So let's find out how they work. What is a wrapper class? Do you remember the basic data types in Java, like int, double, and boolean, when you first learned it? There are approximately 8 distinct types of them, and these fundamental primitive data types are inherently designed to be exceptionally fast and remarkably lightweight in their operation and memory footprint. However, since they're not objects, they don't work well with collections or other parts of Java. You can't store them in those situations. That's exactly when you need something called a wrapper class. Simply put, a wrapper class wraps primitive data types like int or double so that you can handle them as if they were objects, just like how a wrap covers something. So, it's a class that wraps these primitive types. Literally, you can think of it as dressing up a basic data type in the fancy clothes of an object. So, do we have to manually convert between primitive types and wrapper classes every time? Do we need to transform them ourselves? The good news is that Java takes care of this for us. This uses a technique called autoboxing and unboxing. Now, shall we take a look at some examples? Let's say we have a number object defined as an integer, a wrapper class, and we simply assign the value 100 to it. The value 100 is a primitive int type, but this primitive constant, 100, fits right into the variable of the integer object type without any issues. What do we call this? This is called autoboxing. Java automatically wraps the value 100 as new integer 100 for you. Conversely, when you extract the value from the object back to a primitive type, that's called unboxing. In the case of unboxing, it means converting a wrapper class instance into a primitive type. If you assign a constant directly to an existing number object defined as an integer wrapper class, it just becomes a constant. In other words, it doesn't remain a constant, but is converted into the integer primitive type. So, like this, the number object smoothly changes into a constant of the primitive type int, which is 100, and then when you add 50 to it, it becomes 150. So, when an object is used in a calculation, the process of automatically converting it to a primitive type is called a kind of magic. And this is what we refer to as unboxing. So, what are the advantages of these wrapper classes? Can't we just use primitive types? You might think that, but if you use wrapper classes, you can do a variety of things. For example, if you have a wrapper class like integer, you can use it to convert a string you receive into a number. How do you do that? Since this is an int, if you use parseInt, the string is converted direct not to a constant but to a primitive integer type. So, a string like 123 gets converted into the number 123. These methods like parseInt or parseDouble, anything with parse in it, are extremely useful, so it's a good idea to remember them. Another class that you've probably used a lot is string. It's good to remember that strings in Java are immutable. In other words, since string is an immutable object, a class, whose variables cannot be changed. Once it's created, it cannot be modified. It's kind of like a constant. So you might be thinking something like this. You might have used something like this before. You might think, but I can change a string by adding an exclamation mark to it. Doesn't that mean it's mutable? That's what you might think. But actually, that doesn't mean it's changing. Well, in this case, what actually happens is that a new string object containing the exclamation mark is created. And instead of modifying the original string, str now points to this newly created string. So originally there was this thread says str existed, and if it was pointing to certain string, when you do str plus exclamation mark, it now points to the version with the exclamation mark added. And the original one gets discarded like this. So the original str still remains somewhere. The garbage collector will probably take care of it. It's similar to how when you edit a photo, the original stays intact and a new copy is created. So when you modify a string, in reality, a completely new object is created. I've also created another example called the string wrapper test class for this class. So if you take a look at the code before coming to class, you'll probably be able to understand wrapper classes and the string class a bit better. Next, the next topic is ArrayList. Why do we need this? What's noticeable here is something we've seen a lot before arrays. Doesn't it seem like this might be related? The reason we need this is because of the drawbacks of arrays. Let's imagine there's a hotel with 4 rooms. I thought of it as a hotel with 4 rooms. When you first build a hotel, you think 4 rooms will be enough. This is just like an array. You can accommodate up to 4 guests, but one day suddenly a group of 10 guests shows up. So in this situation, what should you do? I'm sorry. There are no vacant rooms. That's what you'd have to say. With arrays, once you set the size, you can never change it. So it can be really frustrating. And that's when, like a savior, the ArrayList appears. An ArrayList doesn't have a fixed size. So it's like a magical hotel that automatically expands whenever you need more space. When a guest arrives, you just use the add method to give them a room, and a new room appears as needed. It's really convenient, isn't it? If you look more closely at the code, to use this, you need to import the ArrayList package. And when you create it, you actually make it as an ArrayList. But you declare it as a list. The reason is that ArrayList implements the list interface, and it's widely recommended to use it this way. So, since we're going to put integer variables into the list, we'll specify integer in the angle brackets. Next, to add elements, you use add to append values to the end, just like you would add values to an array. And if you can add elements, you should also be able to remove them, right? To remove elements, you use something called remove. This works the same way as when we use an index. Here, when you use remove, the number 2 that is, index 2, counting 0, 1, 2, means you're removing the value at the 3rd position in Korean. And size refers to the size. It tells you the current size. So if you look here, we've added the numbers from 0 to 4. So if you put in 0, 1, 2, 3, 4, and then tell it to print, it will print like this. And the initial size is 4 because we put in 0 through 3. And then after removing, if you look at the result, the 2 among 0, 1, 2 will be gone. So now the contents are 0, 1, and 3. And then if you add and insert 5 at index 2, the index 2, which was previously 2, is now changed to 5. You can see that an insert has been performed here. So what if you want to change a value without adding a new one? In that case, the method you use is set. Set is for replacing. It changes the value. It doesn't insert or add a new one. That's precisely how you can effectively utilize this particular feature. Let me summarize. Arrays are simple and fast to use, but their size is fixed. Array lists have flexible sizes and lots of features, but the downside is that they can only hold objects. I just explained wrapper classes to you right before this. I mentioned that you can't put primitive types like int into an array list, but, well, there is a wrapper class for int. So, as I mentioned earlier, if you wrap primitive types like int, double, char, or boolean with their corresponding wrapper classes, you can put them into an array list and use it similarly to an array. Now, let's talk about the concept of generic. Earlier, when we used ArrayList, we wrote something like ArrayList, and there were these angled brackets, the chevrons, and then inside those brackets, we specify the object type, like integer. That's what generics are. The term generics isn't really a commonly used word. It might feel a bit difficult, but actually it's not that hard. It's just a bit annoying. The concept itself isn't that difficult once you try to use it. Generics are kind of like the relationship between generic drugs and original drugs. So with generics, there's the original drug that was first developed. Those have their own price. But when you refer to all drugs, including those, they're called generics, kind of like copycat drugs. That's when the term is often used. Or, let's say you have drinks like Coke, Pepsi, and Sprite. There are cans filled with Coke, Pepsi, Coca-Cola, and all sorts of different drinks. You can put anything in these, but when you actually drink them, you drink from a cup. So you hand someone a cup and ask, do you want a drink? If you want to drink, you can have it anytime. So when you go to a fast food restaurant, they just give you a cup. And if you want to drink something, you go over there where the soda fountain is and fill it up with whatever you want. And when we actually drink, we might have Coke or we might have Sprite, right? But when you actually go to drink, what do you need? The store just gives you a cup and tells you to drink. This kind of all-purpose cup is a type of generic. So, if you have this generic, when you actually want to drink, you just fill the cup with whatever you want and drink it. A generic is a class that takes a type as a parameter. For example, when you create an array list and specify string, you're declaring that this list is exclusively for storing strings. But if you specify ArrayList integer, then it becomes a list dedicated to integer objects. It's like how you can pour either cola or cider into a cup. Similarly, you can store either strings or integers in an array list. But why do we even use this? The main reason for using it is type safety. So, if you specify ArrayList string, from that moment on, you absolutely cannot add an integer type number to it. So, as you're writing the code, it immediately tells you, hey, you promised to only put strings in here and lets you know right away. Thanks to this, you can effectively prevent terrible errors where the program stops because the wrong type was inserted during runtime. Doesn't it feel like having a really reliable bodyguard? It's like, instead of just leaving a cup out and telling people to drink whatever they want, you have a lot of cups at the store. And when a customer asks for cola, you pour cola into the cup and offer refills if needed. But only cola is allowed. That's basically what we're saying. Now, what if there are several options? In that case, you use a comma for the parameters. And if you only want to accept specific ones, this is called a bounded type. You use extends. It's similar to how subclasses and superclasses work. We can also create our own generic classes. So, for example, if you have public class sample, the T here is a placeholder symbol. That means any type can be used. If you set it up like this, you can freely use sample, string, sample, integer, sample, animal, and so on. And we know that this T is a class type, so you can use it just like a class. So you can use it as a data type when declaring a variable, or you can use it as a return type of a method like getData, or you can define something like setData and use it as a parameter type. So you can use it in a variety of ways like this. In this way, the parameter becomes T. Next, T can be used as the type for member variables, as the parameter type for methods, and also as the return type. If more than one data type hasn't been determined in a single generics declaration, then you write 2 inside like this, T1, T2, separated by a comma. And since each can be a different type, you specify different types like this. They could be different types or the same, but in this case, we're assuming they could be different, so we've written it this way. When using generics, you just specify them when declaring the variable, like in this sample demo here. Here, you write integer, string, like this. Then, when you initialize it, you write sample2, and now for the type, so you write the class name and the generic class, but here, you don't need to specify integer and string again inside the angle brackets. You can just leave it out, then it will assume that integer and string have both been specified, just like before. I've defined integer as 3 and string as hello. So now, T1 has been converted to integer, and that's been confirmed through this. Then, when declaring this integer, it's defined as 3. T2 here has been restricted to string, and when declaring it, it's defined by assigning the string constant, hello. But what if you want to accept only types that meet certain conditions, not just any type? That's possible. Of course. Absolutely. It's possible. That's what we call a constraint type parameter. Here's a real example of a constraint type. When we need to compare sizes, the types must be comparable in size, right? That's why we have an interface called comparables interface, and we're going to implement it. We're implementing it, but since it's restricted or bounded by comparable, it's interesting that we use extends here as well. Comparable itself also takes a parameter type, so it's a parameterized class interface. That's why we write T here as well. So we use T just as we've declared it. And since we've specified comparable here, we can use the compare_to method, which isn't available in regular classes. So, because we have explicitly promised that this generic type parameter T within the class definition will definitively possess the compare_to methodsins, we have made that crucial promise and established this contractual agreement by utilizing the extends keyword. We can therefore safely and confidently invoke and utilize that particular method from within the confines of this class, knowing it will always be available and functional. To sum up, generics are like parameterized Classesa treasure chests that can hold anything. We're almost there now. This is the last part. The array list we've learned about and other data structures we'll learn in the future are actually part of the massive treasure chest called the Java Collection Framework, or JCF. JCF stands for Java Collection Framework, which is a unified structure for managing data. it consists of interfaces, that is, what to do. Implementation show to do it, specifically and concretely, and algorithms as well. By using this, you can significantly reduce development time and improve code performance. The reason I explained things like generics so thoroughly today is because I expect you'll be using the JCF in the future. In here, in the collection framework, you'll find blueprints like list, set, and map, as well as actual implementations like ArrayList and later on hash set, which you'll learn about. Plus, it's packed with useful tools and algorithms for things like sorting and searching that use these structures. Because these are used so frequently when we use Java, we can easily and effortlessly make use of powerful data structures as we wish. So, how can we take out and look at the contents of this treasure chest one by one? To open any box and access whatever is inside, you would need a master key that can open anything contained within this collection, which is called JCF. In Java, this kind of master key is called an iterator. So, if you understand the concept of an iterator, you can use the various variables and types in the JCF much more effectively. Using an iterator isn't very difficult. There are two methods. The first is hasNext. This one asks, is there anything else to take out next? That's what it's asking. So it tells you whether there is something or not. And if there is, next asks, so what is it? When you ask that, it responds, yes, here it is. And then it hands you the next item. So before you call next, you need to check if there is an item by using hasNext first. Usually, to use this iterator, as I mentioned earlier, you declare an array list as a list, and this time what we're going to put in it is the animal class we learned about last time. We put in the animal class and filled it with lots of dogs and cats. And then to check these contents, last time we used a for loop, but here we declare something called an iterator. Since we have successfully created a list of various animals, we will also create an appropriate iterator for animal. And then you know the specific variable we declared earlier. We're going to create an iterator for animals. So we declare that animals has an iterator. And then when we run the while loop, since hasNext returns a Boolean value true if there is a next element, false if there isn't, we keep using hasNext from this iterator in the while loop. So if hasNext returns true, when you call next on the iterator, it gives you the current animal. And since the animal originally had a make sound method, you just call that. So whether it's an array list, a hash set, or anything else we learn in the future, you can iterate through them in the same way. It's a really great standard method. So this while loop can actually be changed into a for each loop. Like this, you can use a for loop instead of a while loop. But here, you don't see hasNext or next. However, internally, it's actually using the iterator. But it's just packaged in a prettier and simpler way. So when you effectively use the Java collection framework, remember that utilizing iterators within the JCF is indeed very convenient and highly efficient. So what did we learn today in Advanced Java? Do you remember? First, the wrapper classes that convert primitive types into objects. Next, secondly, the array list, which can change its size freely. Then, generics, which ensure type safety. And finally, we learned about iterators, which can be called the master key for traversing all collections. If you make good use of the concepts we learned today throughout this semester, I believe your code will become much more stable, flexible, and powerful. Great job, everyone!
Yo, I'm coding like a beast in the Java scene. Generics in my flow keep my syntax clean. Parameterized types got me feeling supreme. Type safe vibes living every coder's dream. Collections in my hand like a mic on stage. JCF tools breaking out the cage. Iterator spinning like a DJ's deck. Coding through the night with zero regrets. As I rolling deep, no duplicates allowed. ArrayList smooth, got the crowd feeling wild. Linked list creeping like a snake in the grass. Performance decisions that make my code last. Iterator whispers, let's traverse this space. While loop spinning at a steady pace. Remove on the fly like a magic trick. Generics keeping types so slick. Collections in my hand like a mic on stage. JCF tools breaking out the cage. Iterator spinning like a DJ's deck. Coding through the night with zero regrets.